All right, 10.3, we're looking at parametric calculus. So the first thing we're going to talk about is motion of a particle in the plane. So, if we're given a pair of equations, we're going to think about that as telling us the position of a particle that's moving around over time. And so, what we're going to do is we're going to look at when is the particle moving up, down, left, or right. And so the derivatives that we're going to be interested in are going to be dx dt and dy dt. Now, dx dt, that tells how the x-coordinate is changing as time moves on. So if the derivative dx dt is positive, that means that x is increasing. And if x is increasing, that means that the particle is moving to the right. If x is decreasing, that's when dx dt is negative. It's going to be moving to the left. And in order for it to stop in the horizontal direction, you have to have a point over here where dx dt is 0. It could look like that, or it could look like that. Now, dy dt, that tells you up or down, because it tells how y is changing. When dy dt is positive, that means that the particle is moving up. And if it's negative, it means the particle is moving down. And if it's 0, that means the particle is stopped, probably just for an instant, but stopped going up like this, or stopped going down like that. So let's look at this example. A lot of the stuff we're going to do here, it's very similar to the stuff you did in Calc 1, finding where functions are increasing and decreasing, except now we're talking about x and y independently of each other, and both of them depend on t. And that's also the reason why we're using this Leibniz notation for our derivatives, because we've got several different derivatives going on here. We've got dx dt, dy dt, and we're also going to look at dy dx, but we'll save that for a little bit later. Let's look at this example. This particle's position is given by x equals t squared and y equals t cubed minus t. And this is what it looks like. Now first I want to mention a couple of things. You can't tell from this picture, but the particle starts off down here and moves around like this. So we want to figure out what's the t value. For a while it's moving to the right, or no, I'm sorry, that's moving to the left and up. Then over here it's moving down until you get to this point. And actually, when you're doing this, it's moving left and then right. And then on this part of the trip, it's going right and upward. So we can figure out where all those points are and what time the curve hits those points by looking at the derivatives of these guys. So when is it moving up or down? Well, that's talking about how y is changing. So up and down, we need to look at dy dt. dy dt in this case is 3t squared minus 1. So really what we have to do now is figure out when is this thing positive, negative, and 0. So take it and set it equal to 0. If you do that, you get, let's see, 3t squared is 1. So t squared is 1 over 3. So you get t is plus or minus 1 over root 3. So I'm going to draw a number line over here. I'm going to cut it up at those two places. Those are my critical numbers. And if you plug those into a calculator and see what they are, this one is about 0.57. Actually, 2 decimal places would be 0.58, and this one's negative 0.58. So those are the only places where it can change from positive to negative. So I'm going to move this up a little bit just to give me a little more room. And I'm going to pick a test value in each one of these. In the middle, I'm going to pick 0. And on the outsides, I'm going to pick 1 and negative 1. And now let's look at dy dt and see what happens at each of these. Well, when we plug in 0 into this, you get 3 times 0 minus 1, so it's negative. If you plug in 1, you get 3 minus 1, which is positive. And you get the same thing if you plug in negative 1, since it's squared. So this right here tells us that it's moving, this is dy dt, so it's going up during this part of the trip, then down, and then up again. So I guess I should write out an answer to this one. Is it moving up or down? It's moving up when t is less than minus 1 over root 3 and when t is greater than 1 over root 3. It's moving down when t is in between those two. Like that. Okay, so then to decide when is it moving left or right, you do the exact same thing here, except for you use dx dt instead of dy dt. So let's see, x is t squared, so dx dt is just 2t, but we can do that without even having to write any of this out. My critical number here is going to be 0. And then we'll just have to pick a test point on each side. So if I plug -1 into this, it's going to give me a negative, and if I plug +1 in, it's going to give me a positive. And if it's negative, that means that my first thought there is negative going down, but this is x. So it means that the x coordinate is decreasing, and if x coordinate's decreasing, it means you're going that direction, which would be left. When it's positive, x is increasing, so you're going right. So let's see. So to answer this, it's moving left when t is less than 0. It's moving right when t is greater than 0. And if you wanted to, you could kind of superimpose both of these things over each other, this, and you could figure out when is the thing going northwest versus southwest, or and so on like that. But I don't want to worry with that. What I do want to do is graph this on Desmos and sort of look at this and see that indeed this is where it changes from going up to down, and then this is where it changes from going down to up. So really what we're saying on here is it changes from up to down here. So this is supposed to be t is, let me write this with a smaller pen. This right here is supposed to be when t is about -0.58. And over here, this is where it changes from going left to going right. So that right there is supposed to be when t is 0. So let's graph this thing on Desmos and see this. Let's see, I'm gonna slide this over so we can see more of it. I always get a funny bit of weirdness going on over there at the edge of the screen. Let's see, what's our function? Our function was x equals t squared. And the way you do this is you put in, for x, you put in t squared. Then for y, t cubed minus t. And it gives us this. Now notice it's not showing us the whole thing. It's only showing us the bit where t goes from 0 to 1. So if I change this to, say, -3 to 3, it shows us the whole thing, or at least a bunch of it. If I scroll out far enough, it'll stop. But let's look at that. Let's just go from -2 to 2. And if I want to see the thing animated, the thing to do there is change this one from 2 to some variable. And I'm going to change the endpoints here so that instead of starting at -10, if I pull it back here, you notice it gives me an error because my b now is smaller than my -2 there. So I'm going to start this at the same place. I'm going to let it go up to 2 or 3, whatever. I left step blank, that way it'll do it smoothly. So if I take this and I start moving it, notice it does come up from the bottom. It's going to notice up here where it stopped, or where it changes from increasing, from going up to going down. That happens right there at -0.58 or more accurately 1 over the square root of 3. Then it keeps going down, and here when you hit 0, that's when it sort of hits this side and then curves back. So notice one other thing. We get a horizontal tangent up there at the top. We get a horizontal tangent up here at this point, and we get a horizontal tangent down there, and we get a vertical tangent over here. And that kind of leads into the next thing. Vertical tangents can occur when the derivative dx dt is 0, and horizontal tangents can occur when dy dt is 0. All right, so this is getting long, so I'm going to stop this video here, and we'll do more examples coming up.